Okay, so this is part two of our video lecture for this week. So our next topic would be, previous topic pala, we had our source transformation. Okay, so now we're gonna have like a little continuation lang ng source transform, like a bigger picture lang ng source transform, bigger application, kumbaga ganun. But still sa circuit lang din naman. Okay, so again, welcome guys to our topic or video lecture for this week, part 2, which we'll be discussing Thevenin equivalent circuits. Okay, actually dalawa to, Thevenin and Norton. But before that, let me just recall, ano, di ba if we have two voltage supply which are in series, we can combine them. Tama po ba? We just simply add. If we have two current source na naka-parallel, we can also add them. Tama po ba? Actually, kahit in series or in parallel, we can add. So before, we have been combining voltage supply and current sources. Tama po ba? Yes. Okay. So let's just have recall kung paano ba yung ginagawa. Okay, so we have here the different combinations. So say for example, actually ito sana yung first ko na ano no na ipapakita sa inyo. Kaso pag nakita nyo baka malungkot lang kayo. Oy, ang dami, ba't ang dami? Okay. So anyways, so this one. So say for example, meron kayong dalawang voltage supply, di po ba pwede nating i-add? Okay, kasi same lang naman yung kanilang orientation ng polarity. We can just simply add a VS1 plus VS2, right? If we have this one, naka-parallel siya, same direction, we can just simply copy the arrow sign and then just simply add the current sources. Tama po ba? Yes. And eto din naman, yung ating resistors, pwede din natin siyang i-combine. So, in here, if we will combine these three resistors, so this would be in parallel and then in series. Tama po ba? So, magkakaroon tayo ng R equivalent. Itong equivalent ng tatlong to, which is equal to, again, yung R1 plus R2 parallel R3. Okay? And, eto, if meron kang voltage supply, pero 0 volts naman siya, you can just simply replace it with a short circuit or short. Yes? Yes, kasi this is 0 volts. Wala siyang voltage supply, eh wala din naman to, zero. So same lang. Eto, pag meron kang current supply, and then zero naman yung supply niya, as if wala siyang supply, then you can just replace this with open circuit. Okay? This is how we kill our sources. So we kill it's not really we kill, but pag kinil natin, di ba, yung voltage source, walang voltage drop or voltage. So, ganito siya, short natin. Kapag ikinil natin yung current supply, um, we left it open. Di po ba? Okay. And recall din sa ating source transform na kapag meron tayong in parallel, I mean in series na voltage supply with resistor, we can just simply replace it with this one. Yes? Yeah. And how do we solve for our IS here? This is just simply Vs divided by R1. Tama po ba? Yung R1 natin, ito pa din naman yun. Okay? So, question, ma'am, ano po ibig sabihin nito mga circuit dito, yung mga bilog, itong mga open circuit? Saan na lang to? Kumbaga, ibig sabihin, pwede pa natin itong i-connect sa ibang circuit. Okay? Yung focus lang natin is dito lang. Okay? This could still be connected to any type of circuit. Okay? So, yung focus lang is on this side. Alright? So, I hope na-review po tayo doon. Okay, sabi dito, the behavior of any circuit with respect to a pair of terminals or port, itong pair of terminals, ang tawag na natin dito, port. Okay? Itong dalawang terminal, pwede na siyang tawaging port. Can be represented, yung behavior daw ng circuit natin with respect dito, okay, kung dito ka nakatingin, yung behavior ng circuit na to, pwede nating palitan ng Thevenin equivalent, which is consist of voltage source in series with a resistor. So, eto daw po, pwede natin siyang palitan ng ganito, okay, ng equivalent na Thevenin. So, ibig sabihin, some circuit. Say, for example, meron kang resistors dito, naka-parallel, naka-series, meron kang current supply, voltage supply, gano'n. Kahit ang dami nila dito, pwede din natin siyang palitan ng iisang voltage lang at saka iisang resistance lang. Okay? Itong dalawang to, they represent all of them and yung mga effects ng lahat ng ito with respect to this port. Okay? So, pwede daw yun. Okay? So, kapag na may ganito na tayo, let's say for example, pwede na nating ibalik yung pinaka-interest natin na resistor or load resistor. resistor. Okay? So, halimbawa, eto. Ito na lang. So, say for example, meron kang resistor dito. Ito yung hahanapan doon ng VRL. And then, ang daming circuit dito. Okay? Now, which is medyo complicated na siyang i-analyze. Okay? So, another way of solving daw is you can just simply kunin mo lang yung equivalent or yung nakikita ng RL na to na resistance and voltage. Okay? That would summarize itong behavior ng circuit na to. So, pag nahanap mo na yung equivalent na yun, pwede mo nang isolve na ngayon yung ating RL. See, for example, hinahanap mo sa VRL, edi pwede na, which is easier na. You just have to simply do, pwede mo na lang siyang gawa ng current division. Diba? So, ganun yun. So, ganun yung Thevenin equivalent. Hinahanap natin yung equivalent ng isang circuit, hinahanapan natin ng kanyang equivalent na resistance and voltage. Ang tawag natin sa equivalent specifically is RTH, TH for Thevenin, Thevenin equivalent, VTH for voltage Thevenin equivalent. Okay po. Now, question, ma'am, kailangan ba voltage and resistor in series? What if, ma'am, gusto ko, hanapin ko yung equivalent in terms of current and resistance? Pwede po ba yun? Pwede naman yun. Kapag yun yung hinahanap mo class, ang tawag doon is a Norton equivalent. Same idea, yung mga circuit dito, kinukuha niya lang yung, kumbaga pinaka-summary niya, okay, pinaka-effect niya in terms of current and resistance dito sa ating RL. Kapag hinanap mo yung equivalent na current and resistance niya, ang tawag mo doon ay Norton equivalent. Okay? Now, how do we do that? Ma'am, gusto kong ganito. Say, for example, na-solve mo na. Ito yung nahanap mo. Pero, kung si yung isa, ayaw niya ng ganito. Gusto niya talaga yung current. Okay? Pwede naman. 'Di ba? Using how do you transform this one into current source? 'Di ba? From the previous topic, kapag meron kang voltage supply in series with resistance, pwede mo i-transform into current supply. Pwede. Okay, you just have to do simple source transform. So, ito magiging current, ito magiging parallel. Yung current mo ay VTH over RTH. This one. Naging current na siya. Yeah, this one. So, itong nahanap mo kanina na VTH, RTH, i-transform mo lang class. RTH, still, ito pa yung magiging RN. RN na yung tawag natin kapag ganito kasi which stands for Norton. Okay? Kasi pag current na resistance, equivalent yung hinanap mo, Norton equivalent. Kapag voltage yung resistance yung hinanap mo, Thevenin equivalent yun. Okay? Yung VTH mo ay IN times RTH. Alright? So, let's have example. So, say for example, hinahanap natin, wait. Okay, we'll skip this one. Dito tayo sa baba. So, meron siyang step dito in determining, okay, pwede nyo itong sundan, but didiretso na po ako dito sa more direct approach, okay, para mabilis po tayo. So, ito yung more direct approach. How do we solve for, una, okay, pag hinanap yung Norton, hanapin mo talaga muna si Thevenin kasi mas madali po siya, okay. So, hanapin mo si Thevenin and then you convert it to Norton. So, how do we solve for the Thevenin equivalent? Ganito lang yung tatandaan natin. Magkakaroon lang tayo ng open circuit voltage and short circuit current. Open circuit voltage, short circuit current. Yung gagawin natin sa mga supply. Okay, ganito. Say for example, eto. Okay, hanapin natin si VTH and RTH. So, ito yung interest tayo na resistor, itong RL. Kasi say for example, baka hanapin yung current dito. So, hindi natin siya gagalawin. Okay? So, puputulin natin siya on this side para safe na to. Okay po? So, eto. Dito yung hinahanap natin, puputulin natin dito kasi i-analyze natin itong part na to ng circuit kasi hahanapin natin yung RTH and the VTH and then from there, I'm gonna perform voltage division. So, how do we do that? How do we look for RTH, VTH? Ganito lang po siya. Yung VTH natin is equal to VOC. What is VOC? Yung voltage ng ating open circuit. Remember yung pinutol natin na resistor kanina? Okay, i-remain mo yun na putol. Tapos, i-solve mo yung voltage ng open circuit na yun. Yun na yung magiging VTH natin. Now, what about your RTH? Yung RTH natin, kailangan mo munang yung pinutol natin kanina, remember? I-short mo siya. Tapos, hanapin mo yung current mo doon, which is tatawagin natin this time as C or I short circuit. Tapos, pag nakuha mo na yung current, makukuha mo na si RTH because RTH is just VTH or yung VOC kanina divided by the current short circuit. Okay? And actually, class, itong masosolve natin na ISC or I short circuit, ito na din yung pinaka Norton current natin. Yeah. Okay. Now, ito, pinaka ano na example. So, say for example, meron tayo dito. Saan niya ba kinuha to? From slide 4. So, yung pinaka-problem nito is nasa slide 4. Tingnan natin. Ayan, so this is slide 4. So, ito si RL. Pinutol niya dito. Analyze natin to. So, ito class, ika-copy ko, papaste ko dun sa baba. Ayun, ito na class. Okay, pinutol ko na. Andito yung RL kanina, okay, pinutol ko. So first, hahanapin ko si VTH and RTH. VTH, di ba class, is VOC or yung voltage na open circuit dito? Okay, so pinutol mo siya, hanapin mo yung voltage niya dito. How do you hanap the voltage? Paano mo hanapin? So, ikaw na bahala, okay? So, kung ako, I'm gonna do source transform here. Mag-source transform ako dito, and then, magkakaroon ako ng current supply, di po ba? Eko-combine ko siya dito, then yung resistance, ipa-parallel, and then, hanapin ko yung voltage ng resistance, kasi yun din naman yung voltage ng aking open circuit. Okay? Hindi ko na ipapakita. I-pause yung video at hanapin nyo yung VOC. Kasi kung ihahanapin ko pa dito, medyo matatagalan na tayo. Eh, yun naman yung previous topics natin. 'Di ba? So, makakahanap ka ng VOC na 12 volts. Okay? Which is yun na yung ating pinaka VTH. Next, how do we solve for our RTH? 'Di ba? Hanapin muna si I short circuit. Pag nahanap na siya, VTH is just equal to RTH is equal to VTH or VOC over this one. Okay? So, short ko siya class and then hahanapin ko to. So, based on this, what would be my value of IS? Okay, so ang ginawa niya dito class is nag-nodal analysis siya. So, you have node VS, which is given na siya, and node VA. So, ang ginawa niya, before that pala, no, naka-short to. So, sinong short Masyashort tong resistor. Mawawala to. Okay. So, disregard this one. So, nawala na siya sa kabila. Ma'am, what about the current supply? Mawawala ba siya? No. Because this is a current supply, you cannot short this one. You only have to short out yung resistances and voltage din. Pwede. But current source, it stays the same. So, andito pa rin siya, buhay na buhay. And this short circuit. So, based on this, hahanapin mo na ngayon si ISC, wherein I short circuit natin is equal to itong current na papasok dito, tatawagin natin siyang IR1 because ito yung dumaan sa ating R1 resistor plus your IS. Okay, so at this node, IR1 siya plus IS is equal to ISC. Now, ang ginawa niya dito, nag-nodal voltage siya, so that would be VS minus VA over R1. Remember? Plus IS. Copy. And then, meron na siyang corresponding given dun sa taas. You just simply follow it. You will gonna get to 12 milliampere. So, madali lang naman to. I-pause nyo yung video at saka i-solve nyo. Okay? But kung ako magsasolve nito, hindi ko i-follow tong book. Ang gagawin ko is ito, transform ko ito. Di po ba? So, pag transform ko siya, magiging current supply siya parallel with resistor. Combine ko yung current. Okay? And then, yung resistor ko, short. So, yung current ko ngayon, siya na lang. Di po ba? Which would most probably give me 12 milliampere din. So, i-pause nyo yung video at saka i-solve nyo din using ganun, source transform. So, yung pinaka RTH na natin class is yung VTH kanina na 12 volts divided by 12 milliampere na ISC short circuit which will give you 1 kilo ohm. So, ito na yung ating Thevenin equivalent. So, meron ka ng RTH na 1K, VTH na 12 volts. If hinahanap si Norton class, i-transform mo lang ito using source transform. So, this would be in parallel and your current source here would be 12 divided by 1K which will give you 12 milliampere. The direction would be upward because andito sa taas si positive. Class, yung plus, paano siya naging arrow? Kasi, eto, di ba ganito si plus? Okay. So, eto, nawala ay, so sorry. Okay, so eto, nawala. Ayun na. Sige na nga. Ayun na, naging straight line. Tapos ito class, itong naiwan na isa, ayan, naging curve. So, itong plus, naging arrow. Okay? So andun pataas yung direction ng ating current. Kasi naman dito, 'di ba? Straight tail lang siya. Eh, di paano yan maging arrow? So this one is our arrow. Andun yung direction ng ating current. Okay? So, yeah, ganun lang siya, class. Madali lang, 'di ba? Yes, of course. And class, kung medyo ayaw nyo tong mag-short circuit, ano, pwede din naman, meron pa tayong ibang paraan. Ito, mas gusto ko to. Okay, we have an alternate method for solving our RTH. So, to do that, okay, if the circuit consists of independent sources, kapag ka may mga independent sources and resistor ka lang. Pero kapag ka meron kang dependent, wag mo na gawin tong alternate option na to. Okay? So, kapag ka independent sources and resistors lang meron sa circuit mo, makukuha mo yung RTH mo by deactivating the independent sources. I-deactivate mo, class. Ibig sabihin, yung current and voltage supply, i-short mo. Pag na-short mo na siya, hanapin mo si RTH na dito ka nakatingin sa open circuit mo. Hanapin mo siya dito nakatingin. So kung ako, meron akong R1 and R2, tapos dito ako nakatingin, what would be my RTH? That would be R2 parallel to R1. Okay? So, ganun. Short circuit yung mga, how do deactivate the sources? Short circuit yung mga voltage supply, and open circuit yung mga current supply. Okay? And, yeah, meron tayong mga examples dito. I-try nyo na lang siyang i-solve. Pag may question, just PM me. Okay? I would be very much willing to answer your queries sa PM because in that way, I would know na may pakinaman kayo sa subject natin. Okay? So, one last topic before we end. We have, okay, so next, ano na lang to? Part 3 na lang to. Okay. So, this is it for this topic and see you on the next video. Bye!